So rehashing is basically, as its name suggests, it is rehashing, which is hashing again. Now, why do we have to hash again? So it is required when in a case where the load factor increase. Now, what is load factor? So there can be a thing where we are just performing all the calculation, trying to get the free slot, and somehow we are not able to reach that calculation where we are going to get an empty slot. So we are just doing the calculation on and on and on, and we are not able to get the final results. In such a case, it just increases the complexity. That means the time involved in processing the entire thing. So we are just involving more and more time and just reducing the efficiency of our solution. So in such a case, we have to do hashing again. We have to change the size of our table, and we have to resolve this particular problem with the help of concept called rehashing. So let's see this example, how to perform it. So here we are considering the table size to be 4, and we have exactly 4 values present. So let's start with the first value. Now I'm not repeating the formula. I'll be simply using the division method. So I'll do 10 mod 4. So 4 is the size of the table. 10 mod 4, we will get index as 2. Then I'm doing h of 23, where I'm doing 23 mod 4. So we are getting index 3, which is also unique. Then we are doing 42 mod 4. Now we are getting a collision. So if we are getting a collision, this has not to be underlined. The final one we are underlining. So since we have got collision in this case, we will go for linear probing, suppose. So I'm going for h1 of 42, doing 42 plus 1 mod 4, giving us value 3. Now 3 is already in use, so we'll do h2 of 42, doing the next slot 42 plus 2 mod 4, which is 42 plus 2, 44. 44 mod 4 will be index 0. Okay, so here we have got an empty slot. 3 was already there, so we just went for the next one. Okay, now we will go for the next calculation, which is the next value 52. So I'm doing h of 52, which is 52 mod 4. So 52 mod 4, we will have index 0. Now 0 is already in use, so there is a collision. So we will go for h1 of 52, which is 52 plus 1 mod 4. So it will be 53, giving us index 3. No, sorry, giving us index 1. Yeah. So it is getting resolved at this place. So there is no problem in this particular format of implementing a hashing. But let's suppose it is mentioned that we have to implement a quadratic probing instead of a linear probing. Here what I did was linear probing. Let's suppose I'm doing a quadratic probing. So the same solution I'll be solving with the help of a quadratic probing. So you will be able to see the difference. So now what I'm doing is h of 10, I'm getting index 2. H of 23, I'm getting index 3. So there is no collision here. So no formula implemented other than that. For 42, we are getting the collision. So for 42, I'm doing h1 of 42. Okay. And I'm doing quadratic probing. So here I'm getting index 3, which is used. So I'll go do h2 of 42, which is 42 plus 2 square. 2 square is 4. So 42 plus 4 will be 46 as 2. So in this case, 2 is again already in use. So I'll do h3 of 42. Now 3 square will be 9. 42 plus 9 will be 51. So if we do 51 mod 4, so for this we will be getting index as 4. So the problem here at this index is this index will not be valid as our table size is 4. So starting from index 0, we can go till index 3 only. So we can clearly see here the load factor getting increased. We are just going on with the calculation, but we are not getting our final result. So linear probing was giving us the correct result. But when we are doing quadratic probing, we are getting into this problem of just involving more and more complexity into our solution. So in such a case, we will introduce hashing again, and that will be called as rehashing. Okay, so let's see how to do rehashing. So in rehashing, we will just apply hashing to these same values, but we will just make some changes into the table size. So how we will do it? So apply rehashing. So current table size was 4. What we will do is we will double it. So 4 into 2 will be giving us 8. Now we will not take this 8 even number as our table size. So we have to take an immediate greater prime number. So the immediate greater prime number to this will be, the prime number we will be having next is 11. So the final table size is 11. So now we have to do hashing again with the table size 11 to all these values. So h of 10 will have 10 mod 11, which will give us 10 as our index. H of 23 mod 11 will give us index 1. 42 mod 11 will give us index 9, and 52 mod 11 will give us index again 8. So we can see now that we have got all the unique indices. There is no collision happening and the time got saved. So no extra load factor or the complexity is involved. We are still having an efficient storage of our values. So our final hash table will look like, starting from values, since we have increased the table size now, it will start from 0 to 10 because the size is 11, and the values we are storing at index 10 we have 10, at index 1 we have 23, at index 9 we have 42, and at index 8 we have 52. And that's it. This will be our final hash table without any complexity issues. That is it. I hope you have understood all the hashing problems. And now we will move to the final one called separate chaining. It is the easiest to do and there is no formula involved. So let's see how to do it. Separate chaining is very easier to implement. In this case, we are just going to use the same slot for multiple values. But then how it is possible, as we have till now discussed that it is not technically possible. So yes, we can make it possible if we introduce one more data structure involvement while storing the data. And what we will be using is linked list if there is collision happening while applying the hashing to these values. So let's see how it is done. So in this case, we have first value 10. So the normal division method will be implemented. The size is 5, giving us index 0. For 42, we have index 2. For 73, we have index 3. For 22, we have index 2 again. So we can see that the same index is happening, but now it is possible because of linked list, and I'll tell you how in the final hash table. So this is the easiest form of hashing. Again, we have collision here. So let's see how to do it. So here what we will do is, in our final hash table, when we are putting it for each value that we are storing, for index 0, we have two values. There is 10 and there is one more value, which is 30. And there is no other value, so pointing to null, or we can call it as none. So this is how at this particular index I am storing an entire linked list, and that is how we can store two values or more than two values in this particular slot. Same way at index 2 we have 42 and 22. 42 is the first one, so that will be our head node, and then there will be 22 pointing to none since there are no more values. Then at index 3 we have value 73, and that's it. Our hash table is done. It is easier to solve, and as I said that there are no more formulas involved except the basic hash function we are using. And I hope you have understood all these hashing techniques and collision resolution techniques. That's it. Follow for more such interesting tutorials, and bye bye.